Anyway, as part of my tail conversation, I want to show y'all something. Kevin, do me a favor, hold this heli up. This is a Vibe 90. All right, keep going, keep going.
Around the nose.
All right, let me straighten the arm so it's 90. Okay, so I've straightened the arm so we're 90-90, all right? Not quite, all right. Bear with me here, guys. All right, 90-90. This arm is 90 in line with the boom. Okay, so let's take a look at what we got here. All right, the slider is not centered, but that's pretty much okay. But look at the deflection on the tail blades. As you see, there is, put those up for me, Kevin, without moving the tail. As you see, there's deflection. Straighten them out for me again. All right, Kevin, tutorial number 1.
What's that?
Which way, if the leading edge is pointing a certain way, which way does the tail go?
Against torque.
No. If the leading edge of a blade is pointing a certain direction, which way will the tail go?
The tail will go this way.
That's correct. Okay, so as you see, the built-in pitch when the arm is 90 is against torque. Helis turn in a clockwise fashion as you look down, and the tail, in response to torque, wants to go this way. So what do you need built in? A little bit of pitch to compensate. All right, so that's the Vibe. As you see, 90, pitch built in, good to go. Here's a Vibe 50, same thing. If I was to 90 that arm, same thing, all right? And which way are the blades going? And by the way, it's leading edge control, leading edge control. All right, now let's go take a look at a synergy. Synergistically speaking, hold that up for me. Let's get this arm 90. Okay, just for demonstration, we'll just get it close, all right? See that? Arm 90, right? Arm 90. Let's take a look. Gee, Kevin, which way are the blades going? Against torque, aren't they? Slider's slightly offset, but I want to talk about that a minute. It really doesn't matter that the slider's center. What you're looking for is, that's so much pitch right there, you'd probably stall the tail blades. And of course, over here, he's getting, that's with torque, so you don't need as much. So the geometry on this, damn airplane, geometry on this is good. The vibes were good. All right, we've got no other heli to look at here, it's different. Okay, so this is interesting, since we're gonna do the tail conversation, it's stock T-Rex 600. Lift it up, Kevin. 90 that arm. No.
Why is it?
Get it, no, up. Stop. All right, arm 90. Right, let's look down on the tail blades. Hey, which way's the leading edge going, Kevin?
The right way.
It's going against torque. Even though the slider's not center, but let me show the point. You get plenty of pitch toward the direction of it not being center, and plenty of pitch that way. So setting up rate mode on this heli, making 90-90, servo arm 90-90, works. T-Rex 600 is right. Let's look at the 700, Kevin. All right, I put the blades at 0 pitch. Right, 0 pitch. Let's look at, and as you can see, that is 90. So on the 700, there is no offset. Blades are at 0 when the arm's 90, all right? And that's an interesting thing, because I found on my 700, setting up for not rate mode gives me a better consistency in pyros. But I don't want to argue that. I'm just showing geometries of different helicopters. Kevin, grab the old 450. All right, the old 450, if you look, we 90 the arm, right? Yes, there's some, you 90 the arm, and look, it's 0 pitch. Slider is center, there's no pitch. So the old 450 is like the 700. Center slider, arm 90. All right, so that's a geometry there. Sorry about the heli, but here is another helicopter. This is the Knight 3D. All right, this one has a little bit of different geometry, and it's very much like a Hirobo helicopter. As you see, we've got pitch in the blades going in against torque. If we look at the arm is not, grab the tail. The arm is 90, but what you look at is this right here, this arm, okay, because of this angle and everything. So, but you look at this arm, and that's 90 to the bell crank. And in this case, the tail pitch slider is center. Now, this shaft is so long, you can get a ton of pitch. Obviously, you don't want to go that far. See my videos on building, things will start hitting. And they've actually got a piece of silicone tube to stop you the other way. But, I mean, that blade would be stalled. It's kind of like the Synergy, it goes so far. So, anyway, as you can see, geometry correct here too. 90 arm, some pitch to compensate for torque properly, and in this case, center slider. So as you can see, there's differences from helis. Some will have a center slider, some will have an offset slider. The offset slider's okay as long as with the offset you get enough pitch in each direction, which you can't on some. Anyway, so that's just another heli in the mix. Right, Kevin?
Right.
So what do you, now that you're seeing all this, what do you think?
I don't fly in rate mode anyways.
I know, but what do you think? What's a proper tail geometry after looking at all these different helis?
Yeah, a little bit of against torque. Compensate for the rate mode.
Yep. All right, dude.
All right.
We won't get those.
Okay, here's yet another helicopter. It's called the Logo 500. So let's take a look at this and put the arm 90, and it's pretty darn close. There we go. And check it out. We've got pitch against torque. Again, this design, the slider's offset, but if we check, we get plenty of throw. That would be stalled there, and plenty of throw this way. All right, so there's another helicopter with yet pitch when the arm's 90. All right, so again, we're just showing all these different helicopters and tail geometries, and so far, how many of you guys seen that are all correct, or what I would call
Norm.
pitch against torque when the arm's 90?
Huh?
How many? 1, 2, 3, almost every one of them, right? Okay, cool. Now, does anybody think that that's wrong or right, or?
That should be the way it should be set up properly.
Well,
Pitches against torque.
I tend to argue whether you really have to set up rate, so I won't get it. This is not about that argument. But you got to admit, if you did, you'd have a goal. You know, if you were one of those sticklers to set up rate, you'd have no geometry issues, would you? And then finally, we're going to look at the T-Rex 450 Pro. And this is very interesting. 90 the arm, Kevin. Okay, set the heli down. Let's look at the tail blade. Don't move it. Don't move it. All right, hey, look, there's pitch built in, right? But check it out. Where's the leading edge going, Kevin? Don't unfold it. 90 the arm now. Jeez, I tell you. And look, there's pitch built in. But look which way it's going.
With torque.
It's going with torque. What's up with that? That is not right. I believe due to the counterweight, they made the shaft longer and didn't change the arm. Therefore, if you were to set up rate mode, you'd come over here, and this would be a rate mode setup. Look where the slider is. Okay, seriously, even if you didn't have that much pitch. Look where the slider is, and look at the arm. Turn the heli over carefully. The arm is so far from 90 for rate mode, it's not even funny. All right, so I'll be talking about this more on the bench because I do believe I have a solution to fix it without changing parts or without replacing anything, but we'll come back and check it out.